Now you know what the test is going to look like. All you have to do is what we've been doing on every one of the worksheets. I'm going to go over these 4 examples. This one here, not because you're not, by the way, I was just looking at the test and I have a one that's like this. I'm going to make it worth extra credit for you guys because we didn't do this in as much detail as we did in Chem 1. And I actually had them have to do one that was a double oxidation. And I probably will do that again this year. And I may not even have this class, this part of the class next year for Chem 2. Just doing it because there's several people who didn't do it yet. But anyway, this is not one you'll see exactly like this on the test because it's got double oxidation. But it also illustrates a basic solution, and there's a lot of other little things that you can get out of that one. And all these other ones are very typical of what I want you to see. All right, now let's go over each one of these. The first one's hard because it doesn't have charges. That actually makes it harder. I know it seems crazy, but it really does because at the end, you got to balance everything by inspection. All right, and there's quite a few guys that are not taken care of by my half reactions. Let's start out with the oxidation numbers. Here's a great example of a guy who I don't have, and actually over here too, where I don't have, I don't know everybody in it. I have to make some guesses. Now, there's a couple of ways you could have done this guy. You could have looked at the MnO4 ion on the common ion sheet, or you could just make a common sense approach. Who's going to keep their common state, K or Mn? K, yeah. K is in group 1. He's most likely going to be +1. He's -2, which makes him +7, right? Oxygen here, one of the few. The only one you have to know, peroxide -1, +1.
Yeah.
H2O, H2SO4. You've seen the SO4 ion by now. You probably even know it by heart. -2, +1, +6, right?
Yeah.
And then O by himself, O2 by himself, 0. This is another good example. S changes a lot. Hey, there's certain guys, chromium, sulfur, manganese, copper. These guys change all the time. But so does, these guys are both in the same one. Who do I pick? Well, now, given a choice, I'm going to go with sulfur. But there's 2 reasons for that. One, sulfur is further out in the edge. But here's another reason. See that SO4 again? If you see SO4, 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 they're going to be sticking together like that. Going to have the same charge as you had before. +6, -2. That makes this guy a +2. You would know that because the SO4 ion is a -2. -2, +1, +6. Again, notice the S has not changed, and then O with a -2 and a +1. Got it? Okay. Now let's figure out who's changing. The manganese is going from Mn with a +7 to Mn with a +2. It takes 5 electrons, right?
Yeah.
Everybody good? Make sure I correct any mistakes I make. I think I made a 1 or 2 in the last period. Oxygen O2 with a -1 is going to, and here's a mistake. Oh no, this one, it already has it too. A lot of times it would be an O over here, and you have to make sure you balance it for mass first. One in the future is going to do that. It's already got 2, but there is another mistake we'll make here. People will put +1 electron.
No, it's 2.
It's 2 because you got to multiply by 2 times -1 is -2, 0, 2 electrons. I'll need a 5 in front of this guy, right? And I'm all set. All right. Carry everything down. KMNO4. Oh, yeah. Sorry. 5 in front of that guy and 2 in front of that guy. See, I told you to correct it. Carry everything down. 2 in front of the KMNO4 plus 5 in front of the H2O2 plus, I don't know this guy yet. He will have a coefficient. Yields 5 in front of that O2 from that 5 distributed. 2 in front of this MnSO4. We don't know this guy yet, right? K2SO4. And we don't know water yet. All right. Well, the first thing you always take care of are the other guys. I think there's another one we did like this where we had to take care of, I think it was sodium in front of permanganate, and you had to take care of him first. These Ks are already taken care of. 2 Ks, 2 Ks. I've already taken care of the MNs and the oxygens that are changing from, oh, and that's another good problem with this one. Reason I chose this one. Look, I've got an oxygen in every single one of these guys. Why did I choose these 2? Because they were the ones. Well, first of all, I chose this guy. If there's a peroxide in there, he's the one who's going to be undergoing the oxidation or the reduction. And why did I not go to O with the -2? Because I've got O's with -2s all over the place. Chances are those O's with -2s from this side stayed O -2. And it's only the guy that went to the 0 that I'm going to be changing. Okay, so that was another kind of a lot of this stuff in redox reactors is not a matter of cut and dried, got to memorize this, got to memorize that. It's a lot of stuff, and the more you do of them, the better you get it, the more you recognize what's going to happen in these cases. All right, so I've taken care of everybody but the sulfurs and the oxygens and the hydrogens. Let's take care of the sulfurs first. I got one sulfate over here, I got 2, and one more there. It's 3, so I'll need a 3 there. Y'all do that? Right? You see it? And again, I know he said it's only worth 1 point, and I said that it's only worth 1 point. Assuming you put down reduction for this and oxidation for that, have all your oxidation numbers up there correct, and you balance these guys to each other and within each themselves. But it's nice to get that 1 point. And now that it's a problem because I've got to do all the H's and all the O's. I would recommend the H's because there's only 10 and 16, right? So I would just need an 8 in front of that guy for the H's. Is that right? And if you do want to double check everything, and you should, the number of O's on both sides do balance out at this point. All right? Somebody get that one? Should have. That's a hard one only because of the stuff at the end. All right, nothing really difficult about that one. It's a typical problem. Here's another typical problem. This was an acidic solution, I think. Mg's by himself, so he's 0. -2 plus 5 plus 2, 0. Everybody knows how to get that by now, right? It is plus 5, right? Yeah. Okay. Mg with the 0 is going to Mg with the plus 2. He'll need 2 electrons on this side, and that makes him oxidation. N with the plus 5 is going to N2 with the 0. Now here's a mistake people make. Got to balance it for mass first, and that means I don't need 5 electrons, but I need 10. 2 electrons there, 10 there, 5, 2. Got it? Reduction. Oh, yeah. Sorry. Told you I'll make mistakes. Okay, so yeah, 5 times 2 is 10 electrons. I don't need that. I already have 10 there. All right, good enough. Bring these down. 5 in front of the Mg. When you carry these back down, I didn't have to say it last time because there weren't any guys that had charges. Do not rewrite the oxidation numbers, but do rewrite the charges. MnO3. What am I doing? I am a mess today. Let's see. NO3 with the -1. And he has how many? 2 of them, right?
Yeah.
Okay. Yields 5 Mg with plus 2. And I don't put it to this guy already has 2 N2. All right. So now what's my total charge? There's another mistake we can make here. Total charge over here, plus 10. Over here, -2. So that's 8, right? I need 8. No. Remember your number line. There's actually a difference of 12 between them. Where do I want to put my 12 H pluses? Over here. Got it? And now I also need to balance out the waters. In this case, it's pretty easy. There's no other place there are H's, so how many waters do I need? 6. Okay? Right and the left. All right, good enough. Next one is that's an acidic solution. You can add as many waters or H's as you want to. This next one's also an acidic solution, but he has another little twist to him. He has the same guy involved in both the oxidation and the reduction, as you'll see. I with a -1. Oh, by the way, -2. It makes him plus what, 5?
Yep.
And 0. I with a -1 is going to I2 with the 0 charge, and that will take. Well, we've got to balance it for mass. Take 2 electrons. I with the plus 5 is going to I2 with the 0 charge, and balancing it for mass will take 10 electrons. Got it? Now the problem with this one is you actually don't need to bring this up, but we did anyway, and that's okay. You just have to reduce at the end. I'll need what in front of this guy? 2, and he's oxidation and he's reduction. Right? Everybody go with that so far?
Sure.
What?
5.
Yeah, what am I doing?
Yeah,
I'm having a bad day. Having a bad day. Yeah, I've got 10 electrons gained, 2 electrons lost. I will need a 5 in front of that guy. That gives me 10 lost, 10 gained. Now, I bring these down. Now, a couple of things you can do here. A lot of times people will just, it's a stupid mistake, but it's worth more than just 1 point. All right? I said at the end, if you have all of these things done correctly and transferred down, you're okay. But this will be a bigger mistake. you put the 2 or you put the 5. What are you putting down there? 10. 10 iodines with a -1 plus 2 IO3s with a -1 yields. Now I got to transfer, or got to distribute that 5, and then I got to distribute whatever I've got here. And the answer is not 5 or 1. It's what? 6. It's one of the few times you got the same guy in both of them. I have to add them up. So I have 6 iodines, I2, with a 0 charge.
Oh wait, can you explain how you got 6?
Well, because again, look at watch again. 5 of those are going from here to here, and 1 of them is from there. Now it's the only time you do it. You never add up between 2 guys unless the same guy is in both the oxidation and reduction. It's only seen that a couple of times. All right. So 6 iodines there. My total charge on the left side is -12. This is an acid solution too, right?
Yes.
Okay. So I need 12. A lot of people will do this. They'll put the plus 12 H's on this side. Yeah, it's going to be on this side. Balance it out. And that means I need 6 waters over here. Now, what do you notice about this guy when we're all done? Yeah, I can reduce him. And the reason for that is, again, because of the subscript, I doubled, but I really didn't have to because some of them are going here and some of them are going there, and I really didn't have to do that. But I did it because that's the rule. That's what I've told you to do, and you just have to be careful. 1 or 2 in the whole time we've been doing these had to be reduced, and that will be the correct answers, right? All right. Good enough. What next? Last one, right? This is a tough one. This guy is the one is a double oxidation, and you'll see both arsenic and sulfur are changing, and so is oxygen. So arsenic and sulfur are both being oxidized, and oxygen in the peroxide is being reduced. So we're going to take on arsenic, As2, keeping the subscript, is becoming As. Oh, we forgot to put charges on here. Here's another good example. Arsenic and sulfur, when I do my oxidation numbers, both of those guys change pretty often. You've seen sulfur change, and you've certainly seen arsenic change. But arsenic given sulfur, I'm going to go with sulfur, keeping its common oxidation state, -2, which makes him +3, right? Peroxide, -1 plus 1, -2 plus what in this case? The whole thing has a -3 charge, +5, and then -2 plus 6. We've seen sulfur in sulfates a bunch of times. All right, so As going from a +3 to a +5, and that takes 2 electrons, right? No, because I've got 2 arsenics here. I need to put a 2 there. +10, +6, how many electrons? 4, and that's an oxidation. But unfortunately, sulfur is also being oxidized. S3 with a -2 is becoming S with a +6. Now that, again, is not 4 electrons. Yeah, it's a lot because I've got 3 times -2 is a -6 over here and a +18 over there. It's 18 minus 6 is 12, right? No, it's 18 positive, -6 is 24 electrons. And that's also an oxidation. Now the other guy who's changing is my peroxide. O2 is going from a -1. Now here's another thing about these guys. I said most of the time you bring down the subscripts. So why aren't we going to bring down the subscripts for the O with the -2? Not in this case. Because I've got O's with -2s in multiple places on the other side, and actually more than you think because we're going to have water over here as well, or an OH. Because of that, all I have to do is have a total of a certain number of O's with a -2. Some of them could have been here and some of them could have been there. So I'm going to keep it has to be a multiple of 2 because I've got 2 over there. I'll keep my 2 in front of there, and that means I'm going to have 2 electrons minimum transferred between these. But I did not need to keep 4. If you kept the 4 there, you could have gotten the right answer just by reducing at the end. All right, but you don't have to in this case. Done already?
Yeah, I couldn't get the last one.
Oh, the last one.
Well, I know, but it's like the bonus one I could have gotten, and then the one right on the bottom. I could have balanced it.
That's it.
How did you do it?
Yes. Okay. What do I need to balance out electrons?
Maybe you need 14.
Well, yeah, because I've got 28 total loss. 24 and 4 is 28. And I would need a 14 here. It would give me 28 gained. And that's my reduction. Okay? All right. Have fun. Okay, let's do the rest of this, dragging everything down here. I've got AS. By the way, you notice something. I should mention this about the other one on the base one that I didn't collect. It was a one with chromium in it on the front side. he actually, you're tempted to try to change a subscript here, make one, put a 2 here maybe, or a 3 there, or something like that. Can you do that? Can you change the subscripts for these guys? No, because they're in the same compound. All right, so I would have to double both of them. If I wanted to, if those numbers, say this was an odd number here, and this was an even number, I would have to double these, put 2's in front of both. I couldn't just say, oh, just give me a few more of these. No, you can't do that because they're in the same compound. So both of them have the same coefficient of 1. So that's As2S3 plus 14 H2O2s yields. Now, the AS has to have a coefficient of 2 in front of him. All right, 2ASO4 with a -3. And the sulfur has to have a coefficient of 3 in front of him. 3SO4 with a -2. Where's my coefficient of 28? It doesn't exist. It's not. That's why I said it a little while ago. I don't have to have a coefficient of 2 or 14 or 14 times 2 of 28. Anywhere over here, I have to have a total of 28 oxygens with a -2 charge that came from this hydrogen peroxide. All right, so I'm ready to go. All I have to do is I'll make sure at the end, but I'm ready to do my actual charges. I have a -6 there, a -6 there, so -12. Now this time I'm only able to add OHs with a -1 charge. What side am I going to put them on? This side's got a -12. I got to make a -12 on this side. So 12 OHs. Now be careful. I would make sure I put my parentheses around that. Otherwise it looks like 120 H's. 12 OHs, and that means I need how many waters over here? Well, that's where you're going to balance out everything else. Figure out how many H's you totally have on this side, how many O's you totally have on that side, all right, and it will all balance out. 12 H's, right, and 14 is what? 14 times 2, right, is 28. 28 and 12 is 40. And I don't have H's anywhere else, so I'll need 20 waters here. Okay. So that's one of the more difficult ones, obviously, but you can handle that. It would be in the form of probably an extra credit class. All right.